Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So this video discusses distributed forces in preparation to the internal force systems and the construction of the shear and moment diagrams in beams. Level 16, determine the reactions at the beam supports for the given loading. So here's the given figure. So we will call this F1 and this upward portion as F2. We will call the distance of or the base of this triangular loading, bigger triangular loading, as x1. So this one is 1.5 minus x1. So by similar triangles, x1 as to 900 equals 1.5 minus x1 as to 400 Newton per meter. From there, we can solve x1 equal to 27 over 26 meters. So therefore, this distance is 1/3 of 27 over 26, and that is 9 over 26 meters as shown. And 1.5 minus x1 is 6 over 13. So 1/3 of 6 over 13 is 2 over 13. So that is 2 over 13 meters. Then for the reactions, we have AY, AX is 0. There's no inclined or horizontal loading, then RP. So summation, let's solve for F1. F1 is 1/2 of X1 times 900. So 1/2 of 27 over 26 times 900 is 467.3 newtons. F2 is 1/2 of 6 over 13 times 400, and it is upward. So 1/2 of 6 over 13, 1.5 minus x1 is 6 over 13, times 400 is 92.31 newtons. So summation of moments about B equals 0, AY times 2.5 plus 92.31 times 2.1, 1.5 plus 0.6 is 2.1 minus 2 over 13, then minus F1, which is 467.3 times the quantity 9 over 26 plus 0.6 equals 0. So from there we can solve AY equal to 105 newtons, 105.0 newtons. So since AX is 0, RA therefore is 105 newtons upward. Then likewise, summation of moments about A equals 0, counterclockwise positive. So R sub B times 2.5, the distance between supports A and B, plus F2, which is 92.31 times 0.4 plus 2 over 13, then minus F1, 467.3 times quantity 1.9, 0.4 plus 1.5, 1.9 minus 9 over 26 equals 0. So R sub B is equal to 270.0 newtons, and it is upward. So that's it for this problem. Level 17, calculate the support reactions at A and B for the loaded beam. So here is the given figure. So for the solution, let's call this equivalent loading in this left triangular loading as F1 and in the right part F2. The distance of F1 from the left is 1/3 of L over 3, so it is L over 9. As shown, then F2 from the right is 1/3 of 2L over 3, so 2L over 9. The span is L. So for the reactions, we have AY, AX is 0, R sub B. So summation moment about B equals 0, clockwise positive, AY times L. But before that, let's solve for F1 and F2. F1 is 1/2 of L over 3 times WO. So it is equal to WO L over 6. F2 is 1/2 of 2/3 of L times WO. So it is equal to 1/3 of WO. Then summation moments about B equals 0, AY times L minus F1 times quantity L minus L over 9 minus F2 WOL over 3 times 2L over 9 equals 0. So from there, we can solve AY, which is equal to 2 over 9 of WOL. And this is automatic RA because AX is 0, so RA equals AY equals 2 over 9 WOL upward. Then summation of moments about A equals 0, counterclockwise positive RBL minus WL over 6 times L over 9 minus F2 WOL over 3 times quantity L minus 2 over 9L equals 0. So RB is equal to 5 over 18 WOL upward. Level 18. The beam is subjected to the distributed load and the copole shown. If M is slowly increased starting from 0, at what value MO will contact at B change from the lower surface to the upper surface? So that happens when the reaction at B diminishes to 0. So it will be 0, the reaction at B. So let's call this equivalent triangular loading as F1. Its distance from this end is 1 foot. From A, it's 2 feet as shown. Then we have F2 for this uniform loading. Distance from left and right of the loading as 1.5, 1.5. Then we have F1 equals 1/2 of 3 times 400. So it is 600 pounds. F2 is 400 times 3 or 3 times 400. So 1,200 pounds. Then for the reactions, let's show them. So we have RB and we set RB equals 0 because that's the condition. So summation of moments about A equals 0. So 0 times 12 plus MO, then minus F1 600 times 2 minus F2 1,200 times 4.5 equals 0. So from there we can solve MO and it is counterclockwise. So MO equals 6,600 pound-foot counterclockwise. Level 19, determine the force and moment reactions at A for the beam which is subjected to the load combination shown. So for this loading, for the solution, let's divide this loading into two triangles. And we have AY, AX0, and reaction moment, let us say, clockwise. Then let's divide this linear varying loading into two triangles. You may also divide that into rectangles and triangles if you want. So we'll call this equivalent triangular loading F1 and this one F2. The distance of F1 from this left end of the loading as 1/3 of 5 feet, so 5/3 feet. Then we have F2, the distance of F2 from the left is 10/3 of 10/3 feet or 2/3 of 5 feet. So F1 is 1/2 of 5 times 2, so 5 kips. F2 is 1/2 of 5 times 5, so 12.5 kips. Then summation versus Y, AY plus F1 5 plus F2 12.5 minus 12 equals 0. So AY is equal to negative 5.5 kips. So that means RA is 5.5 kips downward because AX is 0. Then summation of moment about A equals 0, clockwise positive, MA plus 12 times 8 minus 30 times quantity 5 plus 5/3 minus F2 12.5 and the moment arm is 5 plus 10/3 equals 0. So MA is equal to 71.5, keep both clockwise. Level 20, determine the reactions at the beam supports for the given loading. So we have two parabolic loadings. We will call the equivalent loading for this big high intensity loading, parabolic loading, as F1. Since this is a spandrel of parabola, the distance of the line of action of F1 from left is 1/4 of 12. 1/4 of 12 is 4 feet, sorry, 3 feet as shown. Then this right parabolic loading as F2, and its distance from the right is 1/4 of 6, so it is 1.5 feet as shown. So the length of the beam is 18 feet. So first, let's solve for F1. The formula is area of this parabolic loading, which is spandrel of parabola, 1/3 base times height. So F1 is 1/3 of 12 times 200, and it is equal to 800 pounds. F2 is 1/3 of 6 times 100, and so it is equal to 200 pounds. So for the reactions, we have AY, AX is 0, and moment counterclockwise at A. So summation versus Y equals 0, AY minus 800 minus 200 equals 0. So AY equals RA, because AX is 0, so RA is 1,000 pounds upward. Then summation moment about A equals 0, counterclockwise positive. MA minus 800 times 3 minus F2, which is 200 times quantity 18 minus 1.5, the moment arm, equals 0. So MA is equal to 5,700 pound-foot counterclockwise.